Hello, welcome to HackTheFile. This is Michael Lopez, and let's start learning cybersecurity. So, if you look at the screen, today I'm going to be let's talk about my learning experience in college. So, one of the first classes I took in cybersecurity was digital forensics with Kelly Lennox. Now, I really enjoyed the class, but since it was like one of my first classes I ever took, I didn't really understand it too much. And so I did understand it, but I didn't understand it well. And so I would like to go back to the book and just do a quick um, recap on it. That way I can understand it better, and then you can understand it too. Like, so you can learn with me as we go through this, and I'll make it as simple as possible. Now I've looked at the book and I've picked out what I'm gonna do, and I figured if I can do it or not. But I haven't troubleshot it or nothing. So the whole point of my channel is we're gonna go through this book, or we're gonna go through assignments, and we're going to troubleshoot it together. And if I can't get through it, I can't get through it. But if I can, then all the better. And what it does is it helps you troubleshoot it as well, or you can do it with me if you have the book. But here's a little example of all the books I have. So this is the Kelly Lennox book I'm going to be doing right now. Then I have defensive cybersecurity. I have a pen test study guide. I bought these. These has nothing to do with school. Incident response, risk management, IT project management. I have some in Wireshark. So I bought this one separately so I can get really good at Wireshark. Hacking connected cars. So this is actually a book that I saw on Amazon, and it looked really interesting. So I was like, I'm gonna get that and read it, and it's a great read. It's more for people that love to learn the ins and outs and ins of different things. So this is a it's more of a like a advanced or intermediate advanced book. Um, but once you get the concept of diving deep into different things, and you're gonna love that. So and then this is something I bought: information security. This Black Hat Python book I recommend. This is a great book, and I might go through some projects in this, but I this is more for advanced hackers. Like if you want to write your own scripts and not use the tools, or if you can't use the tools you know how to write code. This is more for people like I took to this easy because I was an ex software engineer. So I took to this easy, but I don't think the average person will. But that's a great book. Then I got data structures and algorithms. This has to do with software. A plus certification guides. I got some security plus one. I have the intro to Linux, and these are books that I'm going to be going through on this channel, just to uh, certain things in them. And here's the Windows command line beginners guide. This I'm definitely going to go through. And command line kung fu. I'm definitely going to go through that one. Counter cyber espionage or sabotage. This is actually a book written by the cybersecurity professionals up here in Idaho, the at the INL. And this book is basically everything they've learned how to defend power systems and nuclear power plants and whatnot. This is a great book. I haven't read it yet, but I've heard it's a great book. That's why I bought it, and everything in here I've bought. So this is my personal library of cybersecurity stuff that I like to revisit when if I was unclear on something. I'll go back and I'll run a couple of, and I won't just read it. I'll run some command line, and I'll run some tests and see if I can actually do it still. This is a great book, Building Secure and Reliable Systems. Security Engineering, a guide to building dependable distributed systems. So I went through all these books in school: digital resilience, Thinking in Systems Thinking is a great book. Um, you gotta pick this book up and read it. Systems Thinking. Oh my God, it's so good. Lets you see things in systems and what kind of systems we're using and stuff. Then you got the A plus cram, and then you got Getting Started Becoming a Master Hacker. Now this book right here is invaluable if you're trying to be a hacker. This gives you the little taste of um, of how to do things, reconnaissance, and everything. And then it's a great book. I'll be going through this one too, but I'm sure a lot of people do. But for now, we're gonna do the digital forensics with Cali. I'm just gonna do one. So what I'm gonna be doing is I'm gonna open this book here, and I'm gonna do a. So like I said, these videos, my channel is for um, intermediate to advanced cybersecurity professionals, and so I'm not going to go through explaining in depth and detail um, what digital forensics is in cybersecurity. What what I am going to do is I'm going to do a refresh on it really quick, just in case you forgot, which that happens. And then I'm going to go through one project or something. So, and this is one that I remember doing, but I'm going to do it again. And I'm going to jump from the book to the VM because I'm going to use a Kali VM. Now, so here we go. So how many minutes we got? We're trying to do this under 30 minutes each one of these videos. I don't want to go past 30 or I don't want to go past 40 minutes. So let's see if we can do this in time. We can all have fun and learn something. So, Introduction to Digital Forensics. I'm going to read this a little bit. So, for those of you that may purchase this first edition, the practical aspects of this book have been updated. Okay, so that's fine. It's all going to be the same thing. Okay, so I'm going to go to. Okay, so this is just basically going through. Okay, so here we go. What is digital forensics? What is digital forensics? Let's read this a little bit. The first thing I like to cover in this chapter is an understanding of digital forensics and its proper practices and procedures. At some point, you may have to come across several books, blogs, and videos demonstrating various aspects of digital forensics and the tools. It is of great importance to understand that forensics itself is a science involving well documented best practices methods in an effort to reveal whether something exists. So, digital forensics is basically the people that go in there into recovered devices, recovered hard drives, and they go into a device or whatever, and they recover the data that's in it. In a nutshell, okay. There's a whole. I'm sure you guys know what digital forensics is, so that's about as far as I'm going to go in that. If you don't know what it is at all, you go do some research on it. There's research is everything. So we're going to skip this now, right? And so the start of this book basically goes through the hard drives and memory, and it's just basically brief history. So I'm going to go through here, and I'm going to skip all this, right? Because like I said, you guys should know something about this. So I'm going to skip this, and so I'm just going to show you right here. So chapter 2 goes into installing Kali Linux. So that's what's great about this book, and great about a lot of books. They all show you a step-by-step on how to install Kali Linux, which is, with enough practice, you'll get it down, and it's easy. You'll be able to upload this images and even download the box, and it's all free. I think it's free for a year, so it depends on what you go through for a year. And there's different VM applications. So you have VirtualBox, and it goes through VirtualBox, installing Kali Linux on the virtual machine. That's what we're going to be using. So I'm going to skip all this. And if you're a beginner and you've never done it, right here, it's in this book. So, and I think this book is, and like I said, Packed is my favorite books. I love them. They're really good books. So they give you links to everything. I mean, it's just a vast database of knowledge in these books, man. I love them. Um, so we're gonna skip this since I already got mine installed. So we're gonna go to understanding file systems. So understanding file systems, I'm gonna skip this too because I'm gonna assume that you know file systems. You're gonna know about storage media. You're gonna know about hard drives. You're gonna know about floppy disks. Even though we don't use floppy disks anymore, you're gonna learn about all that. Okay, so flash memory media. You should know about all that. Okay, if you don't, research it or get this book and read it. I'm not gonna go through it. It's gonna take too long. Okay, so we're already at 10 minutes. All right, incident response and data acquisition. So we're gonna start on chapter. We're gonna start on chapter 4, section 3. Okay, and what this is gonna do is it's gonna use a tool in Kali Linux. And what I'm gonna do is let's say for instance I get a flash drive, and they bring it to me. They say, look, I need you to get the data off of this. Um, this is for an upcoming case in some guy that he did this and that, or she did this and that, and we need to get the evidence off of this USB drive. So this is going to go through step by step on how to do that properly, because digital forensics is first of all, you don't want to mess with the evidence, right? So let's say you get that evidence, and there's all kinds of stuff that I'm not going to go into. I'm just going to show you the steps on how to get the data off of the USB, and how to make like a hash file beforehand and then compare it at the end. That's what we're going to do. We're not going to go into the other part of it where data tampering and stuff like that for cases and stuff or whatever. That's as far as we're going to go in this video. Okay, so now I'm going to read these again, like I said. So let's get to the good stuff. In this section, we'll have a detailed look at the tools of acquiring forensic images, data recovery and memory dump analysis, and ransomware detection analysis. This part comprises of the following chapters. Okay, we're going to skip the evidence acquisition and preservation with DC3dd and Guy Magner. Now we're going to do Guy Magner. We're just going to do the DC3dd. Guy Magner, you can I think it's a GUI interface, so you can go in there and you can do it all GUI with the and stuff like that. But I'm going to use command line DC3dd. It's for a basic recap of this. Okay, in the previous chapter, we learned that the documentation and proper procedures are key in the investigation. That's what I just talked about. These ensure the integrity of the investigation by providing proof of data authenticity and preservation of original evidence and documentation, which can be used to archive the same exact results of the uses of tools and methods. Okay? This chapter will demonstrate forensically sound techniques for the acquisition of data using bitstream copies, including creating hashes and keeping the best practices. In this chapter, we'll cover the following topics: device identification in Linux, creating MD5 and SH hashes, using DC3dd for data acquisitions, and then that's all we're going to do. We're not going to erase drives with the data. We're not going to use the DD. We're not going to use Guy Magner. So we're just going to do these three. So device identification. We're gonna go through and say, okay, we're gonna run a list and go, okay, here's the USB right here. I've got it. And then we're gonna create an MD5. I'm not gonna create a SHA because I'm only gonna do one. So I'm gonna do the MD5 hash at the start, and then I'm gonna use DC3dd for data acquisition. Then I'm gonna go look at the log file. That's it. Okay, so we're gonna do that in real time. We're gonna see if we can. And like I said, I haven't done this in a year. So the first tool we use in the acquisition is called Department of Defense Cybercrime Center Data Dump. Okay. It's funny, in cybersecurity they got all these acronyms, right? And they got all these long fancy names. I'm gonna take a page out of Einstein's philosophy where he said, don't memorize things that you can Google. Don't memorize things that you can look up. Okay, I ain't gonna memorize that. I'm just gonna Google that. I am gonna memorize the DC3DD, and I actually, what I would recommend, okay, is, so I have this book, and this is my Red Team Cyber book, okay, and I recommend getting a couple of these books or notebooks and label them defenses cyber, cyber forensics, attacks, attack forensic, attack cyber. And so I've got one order that's coming in. It's going to be the digital forensics book. And what I'm going to do is go through this, and I'm going to write that down. I'm going to write down DC3DD, and I'm going to say and I'm going to put the chapter on here, what it's doing and what I'm doing. So it's evidence acquisition and preservation, right? And I'm going to write down stuff, and I'm going to write down steps as I go through this. So that way, if I forget and I don't want to go grab the book, or I don't have access to this digital, I'll go look and grab my little manual, and I'll open it, and then and it's good to write things down because it burns it in your memory too. So it's just a good practice. Okay, so now we know we're gonna use this DC3DD tool, and DC is a patch of a very popular data dump DD tool that they use. This as, okay, so drive and partition recognition. Okay, new users to Linux and variations may find that drive partition recognition and naming and calcs are different from the Windows service. So this is on Linux and not on Windows. Okay, we'll do a Windows one in the next video. We'll do like autopsy or something like that. Then I'll explain that. Are usually recognized as disk 1, disk 2. Dev refers to the path of all devices and drives that can be read from the written to. So this is basically telling us what the different let me see, how can I say that, just different names. Okay, so /SDA refers to the small computer systems interface, SCSI, SATA, USB drives. These are just names for different files or different whatever. Okay, so the SD stands for SCI, massive storage driver. Like I said, I would write down SD, and then I'd probably put in parentheses SCI mass storage driver, with the letter after representing the drive number. So while Windows recognizes partitions as primary logical, and extended Linux partitions are recognized as numbers. Partition 1 on the drive, partition 2. Okay, so this is identifying the drives that we're going to have. SDB is partition 1 as second drive. Okay. Device identification using fdisk and command. So this is what we're going to do first. For the exercise in this chapter, how many minutes we got? We got 20-something minutes, man. We're not going to be able to do this. So we're trying to go to 40 minutes instead. Device identification using the fdisk command. For the exercise in this chapter, I'll be using an old 2 GB flash drive. And I've got like a 30 GB flash drive, but I only have like 90 megabytes of stuff on it to look at, to log. So hopefully it doesn't take too long to download. If it does, I'll pause the video, I'll let it download, and I'll come back so we don't waste time. Okay, drive for the acquisition is processed using the DC3DD. At this point, we should consider attaching our media to a write blocker. See that before examining. So that's what I was talking about. The write blocker is something that digital forensics people use to keep the integrity of the device you're attaching, and make sure when it's going up for trial or whatever you need it for evidence, it proves that it hasn't been tampered with. You plug it into a write blocker, and then what that does is it preserves the evidence better. So we're not going to go into that. Okay, that's if you want to go into the field of digital forensics, knowing that is one of the main preservation tactics, and it's a big deal with digital forensics. Doing more research on that, read more books about it, is what you need to do. But knowing of it is fine right now. But we're not gonna go to that. I don't have one, so I think it's a physical device, from what I remember. So it's also important to remember to continue using your write blocker when acquiring, creating. So what we're gonna do is we're gonna do an MD5 hash on it. Okay, to do that, and that's good enough. That teaches you some stuff too. To list your devices, ensure that you are aware that before performing any acquisition, the fdisk should be run before any other. The sudo fdisk command may have to be used if previous one does not work. The sudo command, okay, so run the command root, which, okay, so what we're gonna do is, so here's our first step, right? I'm gonna take this off. Actually, I'm gonna go through this, and then I'm gonna move the screen over, and I'm gonna pull up my Kali VM, and then we're gonna run a couple commands. Okay, so the fdisk-1 command has been executed in the following screenshot. Then the 2 GB flash drive, which is my flash drive, is attached. There is one hard disk listed as SDA. The primary partition is listed as SDA1, with the extended and Linux swap partition listed as SDA2 and SDA5, respectively, using the fdisk command to identify devices. Okay, so just go ahead and pull up I'm gonna move this over now, right? And I'm gonna pull up my okay, where's my Kali box? Kali. Okay. All right, here we go. Cool. Okay, so here's a Kali VM. You guys should know how to use one. I'm gonna power this on. Okay, now, this is my Kali one. It's kind of outdated, but it doesn't matter. I think it's a couple versions behind. But for this case, I haven't even checked to see if we have. Well, I mean, it goes through instructions on to how to update your Kali VM and all that. I don't know how to do that, so I'll let this sucker boot. And just give it a second. Yeah, it's all right. Firmware bug. Well, I haven't started this in a minute, but yeah. All right. Oh. Now let's go to full view of this. So. All right, we're at 22 minutes. You can probably do a little quick one of these. So don't look. That's ridiculous. Okay. So, all right, we're booting up this Kali machine. Oh man, this might be the wrong one. Nah, this is the right one. Okay. So I've got all kinds of crazy crap on here that I've been doing for a while, but all right, we'll pull up my. All right, we'll pull this up, and then we'll see if this works. Actually, I got to attach my. I've got to attach my. I've got to attach my. Wait a minute, right there. I'm gonna go to removable devices, and I'm gonna attach. Try to find my. All right, I'm gonna have to pause this real quick. All right, we're back. So I had to switch VMs because the other VM wasn't letting my USB attach, and so here we go. We're back. All right. So now we're gonna go through and run a new VM. We're gonna run this command line. So now I don't know if you remember, it said you had to run sudo fdisk -l, right? It's gonna give me a list of the fdisks on my drive. So as you can see right now, that USB disk that I want to take a copy of isn't showing on here. Okay, this is all just what's on the Kali already. So what I'm going to do is I'm going to come up here and I'm going to attach this. So I'm going to go here, Kingston, connect. Now I'm going to run this, and it still didn't show. So I probably did it too fast. There you go. Okay, so now it's showing right here is dev SBD1. If you remember, if we look at the, and so this has got us 8 gigabytes, and it's got the information that I want to copy. So let's pull up this thing. So if you remember from here, it said it was going to be the SBD1. So let's go through here. SBD is a flash drive to be forensically acquired by the image. So it's going to be called SBD. Now that we've distinguished and became certain of which drive is to be imaged, the SDB drive, we can begin the forensic imaging using DC3dd. Important note, although I have used an older version to demonstrate this, you can use a drive. Okay, so this is just going to be, I think, 90 megabytes. It's going to download and log, so it's not going to take a long time. That was saying if it's going to take longer if you have bigger. So one of my kids are playing something. Okay, so maintaining evidence integrity. In order to provide proof that the evidence was not tampered with, a hash of the evidence should be provided before, during, or after acquisition. In Kali Linux, we can use the md5sum command. I've never ran this successfully. I think I remember when I was in class and I ran this, I couldn't get it to run right. So we're gonna actually try to get it to run this time. I don't know. And I just used the hash tool, hashed it, and then I was done. So there's actually tools like GUI interfaces that you can just run a hash. But we use the md5sum command followed by the path of the device to create an md5 hash of the evidence input file. For example, md5-sdx. You may also try the command with super user privileges typed in sudo md5-sdx. For this example, the 2 gigabyte half drive that I was using is named test USB, is recognized as SDB, so it's ours. And the command I will be using is what's followed. Okay, md5sum /dev/SDB. I don't remember why I couldn't do this last time, but that seems simple enough. So let's move this out the way and let's run a hash on that. So see, you're learning, and at the time, this was like my first class. I couldn't get it to run, but hopefully we can get it to run now. So we're gonna run sudo, and let me pull this back up. Sudo md5sum was dev/SDB1. So that should work. Let's see. Like I said, it's not. Did I do that right? SDB1 sudo md5sum. Man, they're dancing up there, huh? Okay, what's going on? So either it's thinking it's trying to create the hash. Let's see, all right, did that wrong. SDB. Maybe there's no space, but that's it. Dev/dev/FD. That's it. What happened? It's taking a long time. Did it say it was going to take a long time? Okay, so I'm back, and I know why I couldn't do an MD5 sum hash before, because it takes long as heck. And if you don't have if you have a lot of stuff in your USB drive, then it takes a long time. So I emptied everything out, left just a text file in my USB drive, and I went back to my original VM and was able to get the USB hooked up to it. So here's the hash. Here's the MD5sum. Hey, we figured something out. It takes forever. So here it is. It's ends in C37, and that's the name of it. So I was in the process of running a SHA-1 sum, but I was like, nah, I don't need to. It's gonna take forever, and I don't want to work on this longer than I have to. So, but I did learn something. So there it is. All right, let's continue. Let's grab the. Let's go through the rest of this. Okay. All right, in previous examples, the output is MD5 command to get displayed. When performing the acquisition of forensics imaging of the drive using DC3dd, we should also have that exact result when hashing the created image file output to ensure that both the original evidence and the copy are exactly the same, thereby maintaining the integrity of the evidence. So like I said, they should match. This hash file should match the one that I'm going to put in when I run the DD tool. So this right here is just saying let's do a SHA-1, but I'm not. Okay, using the DC3dd. Before we get started using DC3, I need to again draw your attention to one of the features. Being able to wipe data, partitions, and drives. Hence, you may find the DD is sometimes also fondly referred to as data destroyer. Be sure to always, and we can use that in hacking, right? Be sure to always first identify your devices, partitions, inputs, output, files, and parameters when using DD and DC3. These are the features of the DD: bitstream, copying disk partitions, copying folders and files, hard disk drive error checking, forensics wiping of all the hard drives. DC3dd was developed by the Department of Defense Cybercrime Center and is updated whenever DD updates happen. Okay. On-the-fly hashing, hash verification, meter monitoring, writing of errors to files, splitting of output files. So we're not going to split the output file. Verification of files, wiping out files. Important note: although we will only be looking for DD and DC3dd, there's also another tool called DFL-DD. Okay. Unlike previous versions of Kali Linux, DC3dd must now be installed. Okay, so I already have it installed and I have the VM updated, so I don't need. We can skip this, but you can do that, and it's really easy. Installing DC3dd in Kali Linux. Okay, so I already have that installed. When copying an image to the drive, the destination drive should be equal size or larger than the image file, so we should be good because we're doing a small text file. As seen in the preceding screenshot, when using the DC3dd help command, the typical usage looks like this. So we're not going to use the help command, but you should practice using the help command because the help command shows you how to use stuff. So the code terms are used here. If specifies the input file which the device will be imaging. So the if on the command is going to be the USB drive. Hash specifies the type of hash algorithm we will be using. Integrity verification. In this case, I have used the older MD5 hash, so we're going to use an MD5 hash, and it's going to hash it, and then we're going to use that to compare it to the one we just did. And if they're the same, that means that hey, the integrity of the data on that USB drive is okay, and that'll hold up in court. That'll hold up with your job in digital forensics. So it's pretty cool. And I got a feeling ours ain't going to match because I haven't been able to get this right, but it's fine. I hope we do. Okay, log specifies the name of the log file that the logs detail device acquisition in clutting errors. So this is going to be our log file. And of specifies the output file name of the forensic image created by the DC3dd. Although a DD image was specified in the example, other formats can also be recognized by the DC3, including image, as seen as later example. So it's going to be a DD extension on it. The device size should be noted later to compare the output results with the device field. Last line of the display is the progress and status of the acquisition process, showing the amount of data copied, elapsed time, seconds, and the speed of the imaging process. So we're going to go ahead and enter in this command, and I already entered it in because it takes like 30 minutes depending on how big the USB drive is it's copying, and mine should be barely finishing up or finished, but I'm going to type in and run it to show you how that it runs. So let's go ahead and enter that in. So that's what we're going to do. I'm going to go ahead and move this over. Okay, I'm gonna enter it right here. Okay, so it's gonna be sudo dc3dd if, remember that's the USB drive, SDB1. I'm gonna do SDB1 hash equals MD5. We're gonna compare it to our MD5 we did on the top. The log is gonna be DC3 DDUSB, and of it's gonna be test USB. Yes, USB .dd. All right, let's run that. See if it runs. Kelly. All right, looks like it's running. So now it's running, and I'm going to show you that that's running right. But all right, everything worked fine. We'll go up to the top, run it. I don't know why it's doing this. Is weird, but it's because the screen is halfway. So it's running and it's working now, right? So it's making that DD file. So now I'm actually gonna just minimize that, and I'm gonna come to the. All right, now this is the one that's done already. See, so 100% copied, and it's gonna give me my hash right there. And see, the hashes aren't matching now. So I don't know what I'm doing right here. It was wrong right here. So what I'm gonna do is, where's my hash on this? So so this hash ends in C37. C37. So this one is the one I ran, and that ends in, where's the hash at? E4. So that's not matching. But why? Let's go to the top up here, see if that's the same. SDB1. So SDB1, and it probed it, and it gave me 100% output copied, 0 bad sectors, E4. So go back here, E4. E4. Here's my SDB1. Here's my MD5sum. That's not matching. So I have to figure out why that ain't matching. I don't have enough time in this video, but let's look at what this says here. Okay, this says run it, and it's running as SDB. Maybe that's the problem. I run at SDB1. Well, it could have been SDB, right? But I ran the other one as the SDB1 too. So I don't know. Important note: the larger the drive or the file to be acquired, the lengthier times it take. Maybe suggest get yourself a cup of coffee and then wait a minute. So once the acquisition process has been completed, the output results displays as follows. So this is what we got. Obviously, their hash file is going to be different. It's a different source, but there's matches. So there's was 73 at the start, MD5. So analyze the results. We can see the same amount sectors 39164. Let's see if the sector is out. Oh yeah, okay. Amount of sectors have been imagined with no bad sectors being replaced by 0. That we've got that right. We can also see that the exact MD5 hash was created for the image, assuring us the exact copy was created without modifications. So that means there must have been modifications. Oh, wait a minute, I did delete a bunch of stuff off of it, so I might have to rerun this and get back to you guys. So maybe that proves it. If it proves that you can't tamper with the data, if you tamper with the data, it's not going to match. Therefore, I probably would have gotten in trouble. Like, oh, you messed something up. Because I think that I went in there and deleted some stuff off of this to make it smaller. So what we can do is I can pause this and redo it, make sure I get it all right. But what I'll do is I'll just run through this. For now, let's assume that I've tampered with the data, okay, because it's not matching. And then we'll go back and see if I was right. Make sure I don't tamper with it. In the terminal, we can also use the list command. So now we can use the list command, but what I'm going to do is I don't need to run. I can run that list command actually if I want, right? So let's go back down here and oh no, this one might match then because I ran this one after. So we'll see when that finishes and what happens. So okay, so let's run that list command and see what's in there. So there you go, DC3D is in there and the test USB-DD is in there. So that matches. Okay. Okay, to access forensics file, you can home directory. This is just saying where it's going to be at and what's going to be in there. This is also going in there and looking at the files manually. We can do that. It is important to keep the log file to have a record of the acquisition process and its results, which are displayed on the screen upon completion. So this is basically what we got too. Results. Yeah, that was our results, right? I input results. So USB error sector up. In future chapters, we'll be analyzing acquired forensic images using various tools. However, the image can also be copied or directly cloned to another device if the investigator wishes. As an example, we could clone the forensic image acquired previously into a new drive recognized by SDC. The command used to perform this task is followed. So we can clone this to a different drive. In keeping with proper and formal case management, the names of the image file and logs should be unique to the investigator, as you may find yourself multiple images and log files. The location of the image should also be stored forensically or a sound or sanitized drive. So you want to, what it's saying is in digital forensics, you want to label these correctly, and you want to give them unique labels, not get them confused. So this is the file spinning. Okay, that's it. So for the next video on this, what I think I'm going to do is I'm going to try to open this log file that I created in another tool and look at it. So that might be autopsy. I don't know yet. I can't remember. So I'm going to have to go in here and look. But I'm actually going to end the video. But then at the end, I'm going to show whether I was right that I tampered with the evidence, and see if those MD5 hashes match. So everything else worked. Here, here's your stuff. I can go in here and look at the log file that I created from that disk to look at. And they're in here in my home directory. So here they are right here. And here's the DSUP3. And I'm sure you open that in. I'm going to try to open that and see what it does. All right, that opened it in Mousepad. And this is basically the results. E4 hash file. Okay, wait. That's showing a different hash. E4 hash file. So, all right, so I reran it, and let's go ahead and show you real quick. So I'm glad that happened because it actually showed if I did tamper with it, the MD5 files aren't going to match. So that's actually happened. It was a great thing because it showed you like, yeah, you screwed up, you tampered with it. So in here, so what I did was I reran it as SDB. I was right. It shouldn't have been SD1. It should have been SDB. And I did it after I didn't tamper with it. Then I ran the hash file on it, and then I ran the the DC3dd copy right after that. And as you can see, they both match up. So if you look right here, it ends with 9EB, and this hash file is with 9EB, 97B7. I mean, they totally match. So that means that in digital forensics means that file wasn't tampered with, and it can be used as evidence, or it can be proven that yes, I received this source of data, or I checked this device, but I took a MD5 hash file of it first, then I ran the copy, and in between that and the copy, nothing happened. No data was tampered with, nothing was changed, and here's my evidence. And the first time I ran it, I actually did tamper with the evidence. So I took the MD5, and then like I forgot I did that, and after I went and deleted a bunch of files. So that means that yeah, so it works. So this actually did what it's supposed to do. It was freaking awesome. So I'm glad that happened. So here's the evidence on that, you know, either it was tampered with or it wasn't. So that's what the digital forensics is all about. And there's various roles for digital forensics people that you can work for a company and do like attack digital forensics investigations, or you can work for like the police department and seizing devices or hard drives, computers, and you're going to do this type of stuff. It's a really exciting field in cybersecurity. So if you want to know more about it, comment. Let me know if you whatever you want to know more about, or if you want to do another one of these digital forensics videos. I think they're awesome. And so my videos are going to be anywhere from 40 to 50 minutes, apparently, because it takes a long time to actually go through this stuff and read it and get a grasp of a concept of what we're doing, and then I can convey that to you guys. So until next time, this is Hack the File. I hope you had fun, and see you next time.